Myself, S.R.Barbade, Assistant Professor, Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. Today, we will discuss Ladder Logic Basics Part 1, which is in continuation with the earlier video of architecture. Learning outcome: at the end of this session, students will be able to describe what is ladder logic, programming we can say of PLC, which is done by using ladder logic. Contents: first we will see what is relay logic, because in conventional method electromechanical relays are used for control purpose. Analogy between PLC and relay logic: first we will go through the relay logic, then we will see some different input devices and symbols used in a ladder diagram. Then we will see output devices and symbols used in a ladder diagram. If you look at, this is what to the right side, if you look at, this is a electromechanical relay which consists of a coil. Okay. So, this coil is wound on a magnetic material, and these are the two input terminals of the coil which are used to energize the coil. And when the coil is energized, this magnetic contacts attracts, and the connection between this contact is closed. So, a switch whose operation is activated by an electromagnet is called relay. So, this is one of the switch. This is a electromagnet, or we can say coil. So, this switch is opened and closed based on the current flowing through this coil. If there is a current flowing through this coil, this switch will be attracted and this becomes closed. If the current is removed from the coil, the switch becomes open. And this is shown in a ladder diagram with the symbol like this. So, this is a contact, this is the contact, okay, and this contact of the switch is shown by two vertical lines, and this coil, relay coil, is represented by the circle. So, this is a relay coil, this is a contact. So, when this coil is energized, the contact becomes closed. If the coil is de-energized, the contact becomes open. And the contacts are of two types. One is normally open contact, that means when coil is de-energized, the contact is normally open, and when coil is energized, the contact becomes closed. Here whatever is shown is a normally open contact, that means when there is no current flowing through the coil, this contact is open, that is why it is called normally open. But we can construct a contact which is normally closed as well. So, when no current is flowing through the coil, the contact is closed, and when current is flowing, the contact becomes open. So, this type of arrangement is available with the relay logic. So, this is what the ladder representation. Okay. So, ladder diagram of a programmable logic controller consists of two vertical lines called rails, and in between different inputs to the left side and outputs to the right side are drawn. See, for example, these two vertical lines means this is one of the contact, we can call it as a switch also. So, this is switch 1, this is switch 2, and these acts as a input to the PLC. And here this is the output, which is again used as a coil. If this rail is connected with the power supply, for example in AC circuit this is a line, this is a neutral. If coil gets supply when switch 1 and switch 2 both are closed, and coil does not get the supply when either of this switch 1 or switch 2 is open. And each row in this ladder diagram is called rung. In this case there are two rungs. This is the first rung, which consists of switches and coil, and the last rung of the ladder diagram should be the end. Here we will look at different PLC devices. For example, input relays are all there which acts as contacts. So these input relays are physically exist and receive signals from the switches and sensors. Based on the sensor and switch positions, the relay contacts are get closed or open. Then internal utility relays. So these are not physically present, but these enables a PLC to simulate relays. Physically these relays are not present, but through software these relays can be implemented in a PLC. Then counters. Counters, they are simulated counters and they can be programmed to count pulses. So actually these counters are also programmable, which can count the number of pulses, and based on the number of pulses count, the contacts can be made on or off depending upon the number of pulses. Then we can use timers in a ladder diagram. So these also do not physically exist, these timers, because these are implemented in a software, and which increments, these timers may increment from say 1 millisecond through 1 second. That means increment for every pulse of an input signal can be after 1 millisecond or can be after 1 second. This can be implemented. Then we have output relays. These output relays are physically exist and send on or off signals to solenoids or some motors or some lights. And finally, there is a data storage available, which is typically are the registers assigned to simply store the data, or we can say information. Now let us see how the counters are implemented in a PLC. Digital counters output in the form of relay contact when a pre-assigned count value is reached. Okay, so this is what the counter, which consists of register, accumulator and contact, and whatever contact is the output. See, this contact can be either closed or open depending upon the input pulses. Okay, so this accumulator can be reset at the beginning, and these are the input pulses given to the register, and this counts, this accumulator stores the number of pulses, and when particular number of pulses are reached, this contact becomes closed. Otherwise this contact is open. So the same is explained using this timing diagram. So these are the input pulses. This reset is applied at this point. Input pulses are available from this point. Then output is, for example, here activated. Output means this contact is activated or becomes closed at the end of say 5 contacts. Here it is shown after 0, 1, 2, 3, 4 means 5. After 5 pulses, input pulses, after the reset, the contact gets closed. We can change this count from 5 to any other value. Here, how timers are implemented. A timer consists of an internal clock, a count value register and an accumulator. It is used for timing purpose. So this is again similar to the counter. It consists of a clock. This is an internal clock. This is an accumulator, register and again contact, which are the outputs. So accumulator can be reset. This is the internal clock whose frequency we can set. Okay, so this is a clock. On the right side it is explained using timing diagram. Then there is a reset signal, and here we see the output signal. So we can program this timer for counting say 5 pulses, and at the end of 5 pulses the contact contact becomes closed after 5 pulses. If you look at here, it is reset is applied, and after 5 pulses the output, that is contact, is closed here. So this way we can use timers. Now there is a question: name any 2 input and output devices other than mentioned in the earlier slides. You pause the video and answer the question. Answer could be the input devices. As we know, these are push buttons, limit switches. We can say these 2 input device example, and output can be solenoid or motor or any wall. So in addition to the elements used like timers and counters, the switches and alarms, indicators are used in a input-output system. So here on this slide we have input devices with their symbols. To the left side the device, to the right side the symbol used, and the symbol used for normally open operation, and to the rightmost side it is a symbol used for normally closed operation. For example, push button switches. Push button is represented by PB, and this is a normally open push button, whereas this is normally closed push button. Normally open means here when you press this the contact becomes closed, and when you press this the contact becomes open. That is what the difference between normally open and normally closed push buttons. Similarly, there are limit switches called LS, which is normally open, and this is normally closed, and the symbol used in a ladder diagram is this one. Then we have temperature limit switches. So this is also a switch, and here temperature sensor is there. So if some particular temperature is reached, this contact becomes closed, and when some temperature is reached, this contact becomes open in a normally closed contact. Then there is a pressure limit switches. Here certain pressure is applied, and if certain pressure is reached it becomes closed, and in this case it becomes open. Then level limit switches. Level means a liquid level, we can say. So here is a level sensor. If certain level is reached, this becomes closed, and in this case it becomes open. Then here on delay switches. So this is equivalent to the software called timer. On delay means when you activate this, after certain time this is closed, say for 5 seconds or something like that, and after 5 seconds this is open. This is off delay switches. Okay, as soon as you activate this becomes closed, but after certain time this becomes open, and here after certain time this becomes closed. So this way we have different input devices with their symbols which are used in a ladder diagram. These are the output devices with their symbols. If you look at, this is what the contact relay called CR, and this is the contact relay is shown by a symbol. This is a normally closed. Normally closed is shown by 2 vertical lines and 1 angled line, and this is a normally open contact relay. Then just relay, this is a contact of the relay, and just relay is shown by this symbol. Contactor is shown by this symbol. Motor is shown by a circle, inside that M is written. Solenoid wall is shown by this symbol. indicating lamp is shown by a circle, then timer is shown by this TR, counter is shown here, up counting CTR, down counting CTD, like this. References: I use this PowerPoint presentation available from the net for preparing my slides. Thank you very much.